All right, hello. My name is Emmy Brown. I will be your host and presenter tonight. I'm a clinical lab educator here at Vibrant Wellness, and today we will be talking about our brand new test, Toxin Genetics. This is our test launch walkthrough, get to know Toxin Genetics. So before we dive into the specific markers that Toxin Genetics is measuring, we really want to understand why order Toxin Genetics in the first place. Well, to optimize detoxification with tailored lifestyle and dietary plans via assessment of an individual's clinically relevant genetics, or SNPs. What are SNPs? Well, SNPs are single nucleotide polymorphisms. They're genetic variations that can affect detoxification pathways. How? SNPs can impact the function of enzymes involved in detoxification pathways and therefore influence an individual's capacity to metabolize and eliminate toxins. The goal is to use the knowledge of these genetic variants to implement precision lifestyle and dietary modifications that can improve the functioning of enzymes involved in detox in hopes of preventing damaging downstream effects of these toxins. Keep in mind you can also assess the impact of toxins using functional markers such as 8-OHDG, which we'll talk about later, urine or saliva hormones, thyroid panel, gut Zoom or stool test, and others depending on the case. These markers measure the phenotypic expression of the tested SNP genotypes, since we know SNPs represent only the predisposition for the level of enzyme function. And remember, the phenotype is the expression or clinical presentation that we can observe, measure, or monitor. So which patients benefit from this test? Well, there may be patients or clients who already have an established background of neurologic issues such as Alzheimer's, or maybe they're complaining of brain fog without explanation, poor memory. Maybe they have gastrointestinal complaints such as diarrhea or constipation, chronic fatigue, mental or emotional symptoms, sleep issue, multiple chemical sensitivity. The list really goes on. And for these people who really are not given anything beyond symptom support, oftentimes we want to really dig deeper, look at root cause, and see what could maybe be contributing to these issues or exacerbating these issues. And sometimes it can be poor detoxification, because we contend with so many toxins every single day. And if our detox pathways are not functioning efficiently, optimally, then we might have more issues. So a whole long list of conditions are listed here that really may benefit from Toxin Genetics. Let's move on to differentiating the different types of genetic testing in healthcare. There is commercial and medical genetic testing, and these tests look for ancestral origins, traits, carrier status for inherited disease risk. They tend to be disease-based. They might be evaluating pharmacogenomics in terms of how I metabolize a medication versus how you metabolize a medication to help guide medical decision-making in this way. Sometimes they're direct to consumer. Whereas then there's functional medicine genetic testing, which is where Vibrant's methylation panel, CardiaX, NutriPro, and now the Toxin Genetics test fits in, for example. These are going to not be disease-based. We are going to be looking at SNPs wherein maybe we can do something about not changing the SNP because we can't change our genetics, but we can influence the expression of our genes. And maybe these types of tests can look at nutritional delivery and absorption, such that we see in the NutriPro test. Maybe they can help drive lifestyle recommendations and help us be proactive and really look towards prevention with our patients and clients. The focus of Toxin Genetics is detoxification function, primarily as it relates to toxins measured in the heavy metals, environmental toxins, mycotoxins, and the PFAS test, which stands for per and polyfluoroalkyl substances. So we need to note that while the genes in the toxin genetics test may be involved in drug metabolism and disease processes, the toxin genetics test should not be considered a diagnostic test for genetic diseases nor a pharmacogenomic test. So what does the toxin genetics test for? Well, it tests for SNPs relevant to toxin metabolism. And let's talk a little bit more about SNPs. We have some interesting stats here. Each SNP represents a difference in a single DNA building block called a nucleotide. So for example, a SNP may replace the nucleotide cytosine with the nucleotide thymine in a certain stretch of DNA. SNPs are the most common form of genetic variation. They occur in 1 in 1,000 nucleotides. There's approximately 4 to 5 million SNPs in a person's genome. And to classify as a SNP, it must be found in at least 1% of the population. And more than 600 million SNPs have been identified. And note, most SNPs have no effect on health, but some SNPs are linked to diseases like heart disease, diabetes, and cancer. And again, this is why it's helpful to elucidate what these SNPs are so that we can see if there's maybe something we can do to influence the upregulation or downregulation of the enzymes that the SNPs control. Okay, so I know you're all eager to see what the toxin genetics test looks like. Because this is an exciting new test launch. So I'm not going to delay. And so without further ado, let's look at the report. And then later on, we'll go over a clinical case to put everything together so we can apply the knowledge and really make sense of it and understand the utility of the test. As you can see, you don't have to be a geneticist to interpret and apply toxin genetics test results. The report includes an information sheet with test background and interpretation information along with a summary page with an easy to read key at the top, as we can see on this slide, with the information sheet on the left and the summary on the right. The tested SNPs are organized per toxin category. For example, Vibrant offers testing for many specific toxins within the panels organized by category of toxin. So you can order mycotoxins, environmental toxins, and heavy metals individually or as a bundle called total tox burden. PFAS can also be ordered as an individual panel or as an add-on to total tox. And so you'll see on the toxin genetics test, the SNPs are organized per toxin category. You can learn about an individual's identified SNP straight from the report. The comments that will populate will have background information, SNP impact on enzyme function, specific toxins impacted, clinical implications, and suggestions for interventions for each SNP. Think of these comments as a starting place or a guide, if you will. There may be additional toxins that are metabolized by these genes or impacted by the specific SNP and other therapeutic options. And this is really an emerging area. So further research might be helpful beyond the report comments. But good news, there is a toxin genetics guide coming out soon. We're very happy to be releasing that. And so that will help you dig into each SNP in more detail so you can continue to learn and refine and customize your treatment plans. Remember that measuring genetic SNPs is a great start, but to truly put things into perspective, we need to clinically correlate an individual's genetic predisposition with medical history, clinical presentation, physical exam findings, and other significant study findings, such as other lab results. So, the first step really in a detox support program is to identify and limit or avoid toxin exposure as much as possible. So if we can use these toxin tests, ideally the total tox burden plus the PFAS to identify an individual's specific exposures to toxins, that can be a really nice starting place alongside the toxin genetics test so we understand their predisposition and then what they're being exposed to in reality. So we can really hone in and pin down those specific toxins that we want to target. Okay, so how are toxin genetics SNPs tested? We are using real-time PCR, and so the Vibrant advantage of real-time PCR limits likelihood of contamination compared to regular PCR, and it eliminates need for post-PCR analysis. I'm going to skip this slide for now, but you may be asked by clients, well, how safe is my genetic information if I send off this sample to the lab? So I'm going to save this slide for your reference, but note, Vibrant never share genetic information with third parties, and you have this slide to refer back to as need be. Okay. Before we jump into toxin genetics interpretation, there are some terms that I would like to define, and we're going to go through those now. Okay, what are xenobiotics? Xenobiotics are exogenous chemical compounds that are foreign to an organism's normal metabolism and are often introduced from the environment, requiring specific metabolic processes for their detoxification and elimination. Exogenous means outside the body. Think exit. Endogenous means inside the body. And think in. Xenobiotics, these are classified into different categories, as you can see here. We have organic xenobiotics, and this is a category of compounds that contain a carbon atom. They are further subdivided into categories such as pharmaceuticals, industrial chemicals, pesticides, and food additives. Then you have inorganic xenobiotics. These compounds lack a carbon in their molecular structure, and they can be introduced into the environment via industrial processes and other sources. And we tend to think about these as heavy metals, certain minerals, and various chemical compounds. Really, these two categories differentiate xenobiotics based on fundamental chemical characteristics, and understanding the distinctions between organic and inorganic xenobiotics is important when assessing their potential effects on living organisms, their metabolism, and their interactions within biological systems. But the take-home point here really is don't get hung up on the categories. The potential for harm really is based on a multitude of factors, including concentration of the toxin, duration of exposure, and the biological context in which it interacts. Harm from xenobiotics is often dose dependent and subject to a concept known as dose-response relationship. Okay, and what are genotoxins? Genotoxins are substances or agents that have the potential to damage an organism's genetic material, leading to mutations, DNA damage, and potentially contributing to the development of cancer or other genetic disorders. Certain heavy metals damage DNA, causing either single-strand DNA breaks or double-strand DNA breaks or both. And heavy metals can also generate reactive oxygen species, known as ROS. These are harmful compounds that can increase oxidative stress, inflammation, damage DNA, and these ROS must be neutralized by the body's antioxidant defense system if they're really going to be taken care of and not continue to cause harm. I mention this because our toxin genetics test includes SNPs involved in DNA repair, and those are listed here. Okay, so now let's examine phase 1 and phase 2 liver detox and where in the process these tested SNPs may influence detoxification. First, we have phase 1 detox in the liver. Think of phase 1 as the first step in a cleaning process. Lipid-soluble toxins that dissolve in fats or oils are converted to water-soluble substances to prepare for elimination from the body. Then we have phase 2 detox. Phase 2 is like the second step of cleaning. After the mess has been broken down in phase 1, phase 2 kicks in to finish the job. Conjugation reactions add a water-soluble molecule, making toxins less harmful and facilitating excretion or removal from the body. In some cases, we really want to pay attention to the fact that activated intermediates during the liver detox process can lead to oxidative stress. And oxidative stress occurs when there's an imbalance between the production of reactive oxygen species, again ROS, and the body's ability to neutralize or repair their harmful effects via antioxidants. ROS include things like superoxide anions, hydrogen peroxide, and hydroxyl radicals. We really need our detox enzymes working to combat not only exogenous or the externally sourced toxins that we're exposed to, but also the endogenous forms of reactive oxygen species as seen here. Endogenous toxins primarily include the reactive oxygen species from mitochondrial respiratory chain and various intracellular enzymes. Whereas environmental pollution, radiation, cigarette smoking, certain foods, and drugs are the major exogenous sources of ROS. And you can see how all of those are contributing to DNA damage here. If free radical production outweighs antioxidant enzyme activity, or if the antioxidant enzymes are functioning too slowly, we risk oxidative stress and the downstream effects of it, including damage to DNA, as we just saw, but also damage to proteins and lipids, which increases risk for accelerated aging, cancer, and degenerative disease. On the contrary, we need free radicals to a degree to act as signals for upregulation of our antioxidant systems and enzymes such as glutathione. This phenomenon explains why, in part, exercise is so good for overall health. So we have superoxide radicals formed quicker than normal when we are having a really good cardio workout during an intense session, and we need that stimulation for our antioxidant enzymes to kick in. And an example of this would be our superoxide dismutase, when we have that faster than normal respiration, bringing in those superoxide radicals. Here we have a review of phase 1 and phase 2 liver detox processes. I will let you review that later as needed. And note that the excretion of the end metabolites occurs via urination and stool on the far right-hand side. Okay, considering just how critical glutathione is for proper detoxification, we can clearly understand why supplementation with glutathione or a precursor such as with N-acetylcysteine or NAC has become so increasingly popular. But don't forget that there are many whole food sources for glutathione support. And so you can see here on the left-hand side all the nutrients that support glutathione synthesis and all the foods that supply those nutrients. And by the way, I highly recommend the article cited here by Romilly Hodges and Deanna Minnick as an excellent open access resource to start learning about how food can impact toxin genetics. It's really a helpful and well-written article. Methylation is another phase 2 reaction that we can support with whole foods, as seen here. Methyl donors such as B12, folate, and methionine are essential for not only proper detoxification, but also metabolism of neurotransmitters, DNA synthesis, cell membrane repair, and more. And amino acid conjugation is yet another phase 2 detox mechanism requiring amino acids, such as glycine, taurine, glutamine, ornithine, and arginine, available in a rich variety of food sources. And as we just saw, phase 1 detox requires all of these nutrients. Phase 2 requires all of these nutrients. And the antioxidants needed to neutralize the in-between reactive oxygen species that are a product of phase 1 include vitamin A, CoQ10, tocopherol, selenium, etc. And here we have some of the genes tested for in the Toxin Genetics test, organized per phase of liver detox. Note that the genes pictured in the liver are in the liver because this is the primary site of detoxifying or biotransforming, but the toxins that we're exposed to via these enzymes that the SNPs control. But these genes are also active in other sites of the body. And then there are several SNPs that are not listed on this page here. Okay, now that we reviewed the basics of detoxification, let's jump into interpretation and application of the test results, the moment we've all been waiting for. Okay, so I have a couple examples to illustrate the interpretation. We have Jason and Jane. Jason and Jane both have exposures to benzene, but Jane is at a higher risk because her EPHX2AA genotype is increasing her susceptibility to impaired benzene detoxification and elimination. leading to benzene accumulation and the risk for chronic benzene poisoning depending upon the degree of her benzene exposure. And note, she has the abnormal AA genotype because she has 2 copies of the risk allele for this particular SNP. She's got the A, one from mom, and another A from dad. The risk allele may also be referred to as the variant allele because it's the variation or deviation from the most common wild type, or sometimes called the reference allele. The risk allele is that which confers the risk as opposed to the wild type or reference allele. In this case, that reference or wild type allele is G, which we see for Jason. He has won the genetic lottery, just in this case for this SNP, and he's got GG. But do note that genes are not clear cut, and thus sometimes we have to consider exceptions to common understanding. For example, sometimes the wild type allele is associated with the primary risk of concern or another risk as opposed to the variant allele. So oftentimes we think about the variant being the one that's different and posing a risk, but sometimes it's the wild type that actually confers the risk, and it's the variation that offers protection. It just depends on that particular SNP. As a side note, remember, Toxin Genetics is not a medical genetics test, and we are not diagnosing genetic diseases or disorders that are oftentimes defined by specific mutations. So despite the terminology used on the report, I will refer to abnormal or risk alleles or genotypes as the variant type rather than the mutant type. A term of a variation is a lot more person-centered than mutant. As mentioned prior, Toxin Genetics includes a summary page that includes a key as seen here. The risk allele is represented by a plus sign in a red sphere, and the reference or wild type allele is represented by a negative sign in a blue sphere. So you can see that there's 2 little plus signs for homozygous variant. There is 1 plus sign and 1 negative sign for a heterozygous genotype because we have 1 from mom, 1 from dad. And the homozygous wild is 2 little negative signs. We also have the partial risk summary page here, so these are all going to be the heterozygous genotypes listed for the patient. Here we've included a handy reference table that includes all tested SNPs with their associated gene abbreviation, SNP ID, normal, partially normal, or abnormal genotypes, and risk associations on the far right-hand corner, or column rather. So how do we take this SNP raw data and apply it to a clinical case for best outcomes and improved detoxification? Note, I will walk through my strategy, which may resonate with you, but realize that the clinical practice of influencing the expression of our genes with diet and lifestyle is an emerging science with scientific uncertainties and new data coming out all the time. So we must be open-minded and flexible when individualizing cases. So let's revisit Jane's case because she just suddenly got a little bit more complex. Okay, so this is a case study for Jane. She is a 35-year-old female. She presents to clinic with heavy and painful periods, worsening PMS, weight gain, gastrointestinal gas, and bloating and constipation. She drinks 2 to 3 glasses of wine most nights of the week. She is an artist working with paints, dyes, and solvents. She runs and bikes on the busy roadside. Her boyfriend uses a vape pen daily. And she recently moved into an old, musty, as she says, home in Portland, Oregon. Her physical exam and basic lab results were unremarkable, so her primary care provider offered her the birth control pill and a fiber supplement for symptom support and sent her on her way. So my question to you is, would Jane be a good candidate for Toxin Genetics? I think yes. First of all, based on her social history, we know she's getting regular exposure to exogenous toxins. Benzene via her boyfriend's vape pen and motor vehicle exhaust via jogging along the road, xylene from car exhaust and paint, acrylamide from her boyfriend's vape pen, styrene from car exhaust, and possible mycotoxin exposure via water-damaged home. Second, we know she could use detox support because she's not excreting toxins via regular bowel movements, and as a whole, her GI symptoms could be indicative of dysbiosis, resulting in the recirculation of endogenous toxins, such as estrogen metabolites, that may be contributing to a clinical picture of estrogen dominance, worsened by regular alcohol intake. Weight gain could also be a sign of endocrine disruption via various toxin exposure and poor detoxification and elimination. This history may also help us order additional tests for further tailoring of Jane's plan, such as urine or salivary hormones and the gut Zoomer stool test. Okay, so we ran Toxin Genetics for Jane, and here are her results. But what do we do about it? The first step in interpretation is to identify which SNPs belong to which phase of liver detox. If we understand which SNPs and associated enzymes function in which detox processes, we can use an order of operations to customize an effective, safe, and practical detox support strategy. These are Jane's SNPs that impact enzymes in phase 2 liver detox. Wait a second. Why are we going backwards and starting with phase 2? Well, there's good reason for this, and I will walk you through it in a bit, I promise. And here we are reminded of these phase 2 processes that need to be supported because Jane's SNPs put her at risk for compromised functioning of the enzymes involved in these pathways, as you can see here on the right-hand side of the liver. The methylation process is going to be largely controlled by COMT. Glutathione conjugation is going to be influenced by GST-P1, and glucuronidation is going to be influenced by this UDP-2B15. She has SNPs for all three. Okay, while we're on the topic of phase 2 detox, let's take a detour for just a moment, because a discussion on detox wouldn't be complete without mention of NRF2, and Jane needs some help from NRF2, because NRF2 upregulates the functioning of two enzymes that she has SNPs for, GSTP1 and the UDP-glucuronosyltransferase. So you may have heard of NRF2. What's all this talk about it? Well, first we need to understand carcinogenic and reactive intermediates accumulated in phase 1 require activation of phase 2 detox. We saw how that works prior. And then antioxidant enzymes for neutralization and excretion of those reactive intermediates. Sulforaphane from cruciferous vegetables induces the transcription factor NRF2, which in turn upregulates all phase 2 detox enzymes, including Glutathione S-transferase and UDP-glucuronosyltransferase. This is one example of nutrigenomics, known as the use of nutrients to influence the expression of our genes. This is an area that is extremely interesting and fascinating and developing all the time, and it's one of my favorite areas. Later, we'll discuss how we can further use nutrients to our benefit as a workaround for poorly functioning enzymes influenced by our genetics. Because remember, our genes are not our destiny, but an opportunity to tailor our diet and lifestyle for optimal health. And finally, Jane has two SNPs that impact phase 1, CYP1B1 and CYP1A1. The CYP1B1 and CYP1A1 SNPs can impact phase 1 detox reactions. See the Cytochrome P450 enzymes labeled under phase 1 in this slide on the left-hand side of the liver. Jane's last SNP is not listed on the liver detox infographic because it's not directly involved in detox, but it is essential for repairing the DNA damage from various toxins. And that's a great benefit of the Toxin Genetics tests, that we include those SNPs. So let's talk about one of the DNA repair genes, this X-ray repair cross-complementing protein 4. Toxin Genetics tests for two SNPs associated with XRCC4 gene protein, which is essential for maintaining genomic stability and guarding against DNA damage caused by various environmental toxins and insults. This XRCC4 gene encodes for a protein that is necessary for DNA ligation and repair of DNA double-strand breaks. The mycotoxin, aflatoxin B1, acts as a carcinogen and can induce various types of DNA damage, and it can induce oxidative damage also. Therefore, XRCC4 polymorphisms or dysfunction can impair its DNA repair capabilities, leading to the accumulation of DNA lesions, increasing the risk of aflatoxin B1 mediated DNA damage. And in fact, the SNP that Jane has, this RS283385351, has been linked to aflatoxin B1 related hepatocellular carcinoma. That's a liver cancer. So we should probably consider getting Jane's home tested for mold and assessing her for mold illness if the clinical presentation is looking that way, since she does have this compromised SNP, compromised DNA repair rather. Now that we've identified Jane's Toxin Genetics SNPs and suspect that they might be playing a role in her clinical presentation based on a history of high likelihood of exposure, how do we apply this information for optimal detoxification? The best place to start is by reducing exposure. Helping your clients reduce their exposure to toxins has the biggest impact on detoxification. Because if you don't stop putting water in the tub, there's no way the drain can catch up, especially if the drain is slow or clogged. In this case, Jane needs to consider decreasing her alcohol intake, check her home for mold, jog on a forest trail instead of the road, talk to her boyfriend about quitting the vape, and replace her art supplies with low toxin or toxin-free alternatives. Okay, so then the next step is once you've turned off the water coming into the tub, we need to rid the body of toxins and increase their excretion and elimination. So we're talking about phase 3 detoxification, wherein toxins leave the body via stool, urine, sweat, and breathing. And Jane could use a number of therapies here to get things moving because remember, she's constipated. So you can refer to page 53 of the Environmental Toxins Guide for elimination considerations. It's a really fantastic, rich resource available in the education portion of the portal. Okay, so once you've slowed down the flow of toxins coming into the body and sped up excretion of toxins out of the body, what is the third step? The third step is to upregulate phase 2. When explaining phase 2 detox to clients, I usually say that toxins are like little monsters running around in your body causing trouble. Nobody wants to handle monsters because they are scary and they have sharp teeth. And however, if you can put the monster in a box, i.e. conjugate it with a water-soluble molecule, all organs can help transport the monster out of the body. Notice the arrow, it's bicolored. We have yellow on the left and blue on the right. And so the yellow on the left is representing fat-soluble compounds that are then being converted into water-soluble compounds on the right. By making toxins more water-soluble, if you put the monsters in the box, all of a sudden the body can better handle and transport these toxins from the liver to the kidneys or the gut so they can be eliminated as urine or stool. I have to give credit where credit is due. This analogy was designed by my brilliant colleague Adair, and I just couldn't help myself because it was too good to pass up with those little monsters. All right, so now that we've slowed the flow of toxins into the body, increased excretion, and we can officially put the monster toxins in the box, what is the last step to focus on and upregulate when supporting detoxification? You guessed it, it's phase 1, and that's why we're starting with the phase 2 review of Jane's SNPs just prior. Phase 1 activates fat-soluble toxins, so a polar water-soluble compound can be attached to it in phase 2. Remember, activating toxins makes them more toxic, and activated intermediates create reactive oxygen species. For this reason, the liver needs ample antioxidant support. Okay, thinking critically here, what happens if you support phase 1 detox before phase 2? Well, if you upregulate phase 1 but fail to upregulate phase 2, you quickly run out of boxes to put the monsters in. which results in an abundance of activated and irritable monsters, creating reactive oxygen species running around in the liver and wreaking havoc, using up all of your antioxidants. So we really need to have properly functioning phase 2 before we start supporting phase 1. So we don't have that backing up of those reactive oxygen species. Okay, now that we've devised a stepwise approach, we can insert individualized therapies into the steps to positively influence the expression of Jane's SNPs. First, let's define a few terms. Substrates are the molecules that undergo enzymatic reactions like toxins. Inducers are the substances that promote or upregulate the activity or expression of enzymes involved in liver detox pathways. This increased enzymatic activity can result in the more rapid breakdown of these substances. Inhibitors, on the other hand, are substances that decrease the activity of enzymes involved in liver detox pathways. Inhibition can lead to reduced metabolism of drugs and toxins, potentially resulting in increased blood levels of these substances. This can lead to increased toxicity. Ultimately, inducers upregulate enzyme activity and inhibitors downregulate enzyme activity. This can influence the toxicity of the substrate, making it more or less toxic. We learned that our first step is to support phase 2 detox. So let's take a look at Jane's SNPs involved in phase 2 in a little bit more detail now. This is the fun part. Starting with COMT. The COMT gene encodes for the enzyme Catechol-O-methyltransferase and is well known in the functional medicine space due to its wide spanning effects. This enzyme plays a crucial role in phase 2 metabolism of various molecules possessing catechol structures, such as catecholamines, estrogens, drugs, and xenobiotics. This variation in the gene results in decreased enzyme activity, leading to decreased degradation of xenobiotics and estrogen metabolites. As a result, poor enzyme function may lead to increased sensitivity to environmental toxicants and poor or incomplete metabolism of estrogens. So how may the COMT SNP be impacting Jane specifically? Well, poor detoxification of xenobiotics overall, and poor detoxification of estrogen metabolites, possibly contributing to menstrual irregularities and hormone imbalance that we're seeing in the clinical presentation. Furthermore, note that impaired metabolism of estrogens may increase cancer risk through persistent oxidation of estrogen quinones and formation of depurinating DNA adducts unless metabolites are rendered inert. We can support COMT via the inducers listed here. You see those methyl donors and cofactors involved in COMT activity on this slide. And also be mindful that a diet high in sugar may thwart our efforts. Also consider further workup with neurotransmitters and saliva or urinary hormone tests, which we offer also. For patients with COMT polymorphisms, since these systems may also be impacted by a poorly functioning COMT enzyme. Next, we have GSTP1. GSTP1 gene encodes for Glutathione S-transferase P1 enzyme. GSTP1 is a member of the Glutathione S-transferase family, which plays a critical role in cellular detox processes, particularly in the detoxification of benzidine, styrene, arsenic, cadmium, mercury, pesticides, tobacco smoke, alcohol, mercury, and various xenobiotics. GSTP1 variants can result in decreased enzymatic function. Note that this phenylglyoxylic acid PGO is a styrene derivative on the environmental toxins test that we can measure. Okay, so how may these GSTP1 SNPs be impacting Jane? Well, she can have an increased risk of asthma associated with air pollution. Remember, she's jogging on that busy road. She could have higher levels of lead and mercury. She probably has some of this estrogen metabolism pathway impacted and a possible increased risk of breast cancer secondary to that mechanism that we just mentioned on the slide prior in terms of breaking down those estrogen metabolites and any compromise there. We can support GSTP1 via the inducers listed here can see resveratrol, cruciferous veggies, allium veggies, garlic, fish oil, curcumin. And supplement recommendations, possibly considering the optimization of glutathione levels with grass-fed whey protein powder, which is rich in cysteine, which is a major building block for glutathione, or just using NAC or liposomal glutathione, and recognizing that we can test glutathione levels on the micronutrients test. Next, we have UDP-glucuronosyltransferase 2B15. She has this SNP, and the UGT2B15 is primarily involved in the glucuronidation process. UGT2B15 targets various substrates, including BPA, parabens, steroid hormones, fatty acids, drugs, and other xenobiotics. UGT2B15 variants can result in decreased enzymatic function, reduced drug metabolism, and increased susceptibility to BPA and paraben toxicity. Note that BPA and methyl ethyl propyl and butylparaben are all tested on the environmental toxins test. So what can we do about this? You can incorporate foods that are known to induce UGT enzymes as listed here. And also, I think this is a really great time to talk about beta-glucuronidase and calcium D-glucarate. I'm sure some of you have heard about this connection, particularly in terms of the gut microbiome. So time for another little detour. We have D-glucuric acid, commonly referred as and available as the supplement calcium D-glucarate. And this has been theorized to inhibit beta-glucuronidase, which is a microbial enzyme found in the gut microbiome. Beta-glucuronidase is something that you don't want to be too high because it can reverse UGT conjugation reactions, which may lead to recirculation and reactivation of estrogen metabolites, which were meant to be excreted, thereby possibly resulting in an increased risk of estrogen-related carcinogenesis. It is important to recognize that research is still preliminary and there exist knowledge gaps regarding the microbial beta-glucuronidase estrogen metabolism breast cancer axis. That is a mouthful. So is there value in supplementing with D-glucuric acid or calcium D-glucarate or eating more of it, particularly for someone like Jane who has a SNP that compromises the UGT enzyme activity and has suspected dysbiosis? Well, one human study showed that the addition of D-glucuric acid-rich foods to the diet showed no effect on beta-glucuronidase activity. Yet, in vivo research suggests that another food-based nutrient, namely a polyphenol extract of black currant, may inhibit beta-glucuronidase activity in the intestinal lumen. With that said, my takeaway is that a whole foods diet rich in polyphenols, rather than supplementation of calcium D-glucarate, is most likely the safest approach to supporting UGT activity via addressing high beta-glucuronidase. Note, beta-glucuronidase can be measured on the Gut-Zoomer stool test. And don't forget, you can also run the micronutrient test to look for the glutathione status as mentioned previously, to really understand if supplementation is necessary or not. Now let's look at Jane's phase 1 SNPs. CYP1A1 converts xenobiotics into more water-soluble forms that can be conjugated in phase 2 liver detox. CYP1A acts on various xenobiotic compounds, including environmental pollutants, carcinogens, drugs, and polycyclic aromatic hydrocarbons. These can be found in tobacco smoke, exhaust fumes, and other combustible products, as well as heterocyclic amines formed during cooking meat, poultry, and fish at high temperatures. CYP1A1 also acts on steroid hormones, with its impact on estrogen metabolism being particularly important for Jane. And remember, because this is a phase 1 enzyme, CYP1A1 activates procarcinogens into potentially more potent carcinogens. CYP1A variants can result in upregulated enzymatic function. So this is a difference here. We looked at phase 2 SNPs, And in those variations, there was downregulation. So slowing down of phase 2 is really not where we want to be, because we don't want those reactive oxygen species building up, those intermediates after phase 1. But in this case, this is a phase 1 enzyme that's being impacted by Jane's SNP right here. And this variation is resulting in an upregulation of enzymatic function. And of course, we need to go through phase 1 to get to phase 2 and excrete these toxins out. But if this phase is too fast and phase 2 is too slow, we have issues, as we talked about prior. So intervention considerations include increasing intake of antioxidants to offset and reduce the impact from the reactive intermediates produced after phase 1. Consider including inhibiting agents to effectively slow down metabolic activity of CYP1A1, as noted here. Turmeric, black raspberry, blueberry, black tea, and ellagic acid, to name a few. And notice, turmeric has been found to be both an inducer and inhibitor of CYP1A1 enzyme function. Nutrient-based enzyme inducers and inhibitors demonstrate bifunctional modulation of enzyme activity dependent on factors such as dose, duration of therapy, and isolation of bioactive compounds. Even other factors may weigh into the overall dietary impact on gene expression. For example, the impact of food on GST enzyme function may be impacted by gender and even possibly body weight. This is why a diet focused on plant-based, whole, unprocessed foods is currently thought to be the most reasonable, safe, and effective approach to supporting optimal gene expression. You can also support other systems in the body that might be impacted by increased CYP1A1 activity, including estrogen metabolism. Think DIM and cruciferous vegetables for that. And her last SNP here is the CYP1B1 gene, which plays a vital role in the initial step of phase 1 metabolism. And this one, once again, can upregulate enzymatic function when there's a SNP. This gene is involved primarily in the metabolism of xenobiotics, drugs, and environmental toxins, but also the hydroxylation of estrogens. And remember, impaired hydroxylation can increase the risk of hormonal carcinogenesis, once again, really important for Jane. Consider supporting the SNP with inhibitors at first, while prioritizing phase 2 as to not overwhelm phase 2. And so we can see all the inhibitors here. Stilbene comes from resveratrol, grapes, peanuts, flavonoids, apples, berries, cherries, soybeans, lots of options there. Okay, so in summary, we can use Jane's case to illustrate how to apply results from Toxin Genetics to improve detoxification pathways in hopes of improving downstream symptoms associated with toxin exposure, hormonal imbalance, and a dysregulated gut microbiome. First, you identify and avoid toxin exposure, support excretion, support phase 2, support phase 1, consider additional testing, and focus on a plant-based, unprocessed whole foods approach. And if you don't know about 8-OHDG, as listed here amongst these other tests that might be useful to further evaluate Jane's case, including urine and salivary hormones, gut zoomer, micronutrients, and neurotransmitters, we will learn about 8-OHDG here. 8-OHDG stands for 8-hydroxy-2-deoxyguanosine. 8-OHDG is a marker of oxidative damage to DNA from reactive oxygen species. As I mentioned earlier, oxidative stress can occur due to many factors, but toxins are a major contributor, and a sign of that oxidative stress may be high levels of 8-OHDG. 8-OHDG formation is considered to have a close relationship with tumors, cell aging, exposure to xenobiotics, cardiovascular disease, and other degenerative diseases. So it's a really nice marker to help monitor oxidative stress in maybe someone who's resistant to be compliant with a more whole foods diet, and maybe they're not really on board with the plan. Well, this is a nice marker to say, hey, I think that we really need to make changes because there are some links here and risks that we need to consider and we would really want to avoid. The good news about this marker is that a diet rich in colorful fruits, vegetables, and polyphenols has been shown to reduce 8-OHDG. And you can find 8-OHDG as part of Vibrant's urine hormones test. In conclusion, the current research suggests that using a plant-based, unprocessed whole foods approach rather than high-dose supplementation is likely the most reasonable, safe, and effective approach to supporting optimal detox because we know nutrient-based enzyme inducers and inhibitors demonstrate bifunctional modulation of enzyme activity dependent on factors such as dose, duration of therapy, isolation of bioactive compounds, and other factors. And lastly, keep in mind, lifestyle factors such as exercise, smoking, and stress also plays an epigenetic role on enzyme function that warrants further study. The take-home point is this. We can leverage the knowledge of one's genetic makeup to design treatment plans that assist gene expression in an effort for optimal health. We all need a little help at times. These detox support strategies are akin to a coach cheering us on through to the finish line, the doula offering emotional support for a low-stress labor, or a physical therapist helping to rehabilitate a repetitive strain injury. If we find the right ones, they really bring out the best in us. For more information on specific toxins' clinical implications, sources of exposure, and management strategies, don't forget to take advantage of Vibrant's educational content. We have a comprehensive guide for each category of toxin to accompany the markers tested on corresponding test panels. Thank you so much for joining me.